Hello everyone, this is Zelin's class and welcome. In this class, you are going to learn how to use the formula of ln x differentiation to solve questions. And also, you are going to learn what is the differentiation formula for trigonometry functions. And now, this is what we did yesterday, which we proved that the differentiation of ln x is equal to 1 over x. This is our proving. And there's another interesting formula, which is the formula for log, the differentiation of log. Although it's not in the curriculum, but it's quite interesting and you should know it, which is y dash equals 1 over ln a times x. And this is just an extra point because you won't get tested. And now let's conclude this. Our important formulas. There's one is we have just talked about it, which is y equals ln x. However, the second one, which is y equals ln fx, the differentiation of y is equal to f dash x over fx. Well, to prove this, it's quite similar to the proof of e to the power of fx differentiation. And if you are not quite sure about this, you can check my previous video. And now let's do, this question. So I want to let all of you to try it by yourself because we have done a lot of gradient questions already and you should have the skill to solve it now. So I'm going to skip it. If you got the answer, you can leave a comment below and tell me what is your answer and I will check for you. So now let's do a question that is very different as others. So it is find the differentiation of dy over dx in terms of x for this equation, which is e to the power of y equals 2x squared minus 1. Well, we know that dy over dx, which means it's y dash. However, if we don't know what the y equals, we can't solve y dash. So our aim is to change this equation into the subject of y. So how do we change this? Because we can't solve it by now. So how do we do it? Well, we can see that the base is e, so why don't we add ln on both sides? Which will get something like ln ey equals to ln 2x squared minus 1. So why do we add ln? Because we know that ln is log base e. And here is e to the power of y, which means that we can bring the y to the front. And this will becomes y ln e. And we know that ln e is equal to 1, so which means that this is equal to y, and y is equal to ln 2x squared minus 1. So this is the first step that we have converted this equation into another equation. And they mean exactly the same thing. And now we can do the differentiation by using the formula ln fx. So we have y dash equals to 2x squared minus 1 dash over 2x squared minus 1. And this is equal to 4x over 2x squared minus 1. And this is our answer for this question. Okay, so now let's move up to the trigonometry differentiation. Well, this part, it's quite easy to remember, but it's quite hard to prove. The proving is not in our curriculum because it is related to something called limit, and you are not going to learn this year, I think. So, or maybe it's in the later of the year, so we are not going to talk about this currently. And now let's just try to look at the three formulas, which is sine x, cosine x, and tangent x. Well, to remember this, it's quite easy. So when you see sine x, it will convert into cosine x. And when you have cosine x, it will convert to negative sine x. And for the tangent, it will be 1 over cosine squared x. Well, for the tangent x, I can prove it for you, which because y equals tangent x, and the tangent x is equal to sine x over cosine x. So, now we know that. Now let's do y dash. We can use our quotient rule that we talked before. So you can check my previous videos about quotient rule. And so we can solve it because this becomes cosine squared x and sine x dash cosine x minus sine x cosine x dash. And by using these two formulas, we get a sine x, the differentiation of sine x is equal to cosine x. So this is sine x dash is cosine x times cosine x. And here, cosine x dash is negative sine x, so which becomes negative sine x squared over cosine x squared x. And this is becoming cosine squared x plus sine squared x over cosine squared x. And we know that sine squared x plus cosine squared x is equal to 1. So this is equal to 1 over cosine squared x. And we solved it. So this is the end of this session. And we are going to do more questions around trigonometric derivative of trigonometry functions tomorrow. And I'm going to introduce you a channel which is by Daniel Dallas. And he is doing GCSE math. So he is doing those videos. And his video is explaining very well, and I think it's very suitable for the students who like GCSE math or currently doing it. And there are a lot of fun questions in his channel. And make sure to subscribe both of our channels, and see you again.